The objective today is to create a function that updates correctly based on user input. So last time we met, we looked at a DOL that asked you to create a function that will allow the computer to switch the player. So what we're looking at here in this exemplary example is the function called switch player. So what this does is if the current player is equal to 1, then it's going to take that current player variable and go ahead and change it to player 2. Change it to 2. And then it'll show on the app itself a player 2 highlight. So that gray box is going to pop up on top of the label player 2. And then for the label player 1 that's already highlighted, it's going to go ahead and hide that highlight, hide the gray box. And that's all going to happen if the current player is 1. So it's just switching the player from 1 to 2. Now if it's already player 2's turn and they just finished, then current player will be changed to 1 and the player 1 highlight is going to be shown while the player 2 highlight is hidden. So you can see the patterns here. And then in my console I'm going to print out current player and then tell me what number the current player is. And why would this be helpful? So if I'm on my console and I'm watching somebody, 2 other people play a game using my app, I should be able to see player 1, player 2, player 1, player 2. And if that's not going on, then maybe someone's cheating and I need to look at my code and see what is allowing that cheating to take place. Or even if there's not a nefarious person working on playing my app, this information will allow me to see if there's any bugs in my code. So basically, I just finished narrating this code myself. I want you to go ahead and do that. Seeing how you have to do that for the test, we'll do a quick practice here. If you're immediately intimidated, go ahead and just rewind and listen to how I narrated this exact same piece of code and then try to do something like that. So today we need to increment a variable to reflect increases and decreases in a player score. So here's an excerpt from the paired programming conversation between Michael and Alexis. Michael starts off by saying, to update the score, we actually need to know 2 things. If the correct button was pressed or not, and which player's score we need to update. Then Alexis says, well, first of all, it sounds like we need a new global variable to keep track of each player's score. And why would it be a global variable? Well, because this variable is going to be used in a couple different functions. So here's some pseudocode Michael just typed up real quick. So what Michael's thinking here is if the correct button is clicked and it's player 1 clicking it, go ahead and add 1 to the player 1 score. Or else add 1 to the player 2 score, because if it's not player 1 clicking it, it must be player 2. Now if the correct button is not clicked, down here we have a different else statement. If the correct button is not clicked, player 1 will get a subtraction of 3 from their score. Or if it's player 2 who had made the mistake, then it's player 2 who's going to receive -3. So what do you think of that so far? I mean, it's a couple nested if statements. What do you think about this solution? Think it'll work? Now Alexis says, I just thought of a third option, and don't hate me for suggesting this, but we could make another function called something like update score by, and then there's an amount to add. And this function's whole job is to figure out whose turn it is and to add the amount given in the parameter to the correct player's score. So Michael says, interesting, but what if we need to subtract from the score? Do we need a whole new function for subtraction? And this is funny Michael says that because just yesterday I was working with a student in 3rd period on his code, and it was a fresh look for me. I hadn't seen this code for a while for a particular game, the up button game. And so him and I were looking at how to solve one of the problems in the code, and I just initially jumped to creating a new function. I kind of just create tons of functions anytime I need something new, and in a little bit I'll tell you why that's a bad thing. But for me, I just created this new function. We figured out not too long afterwards, after we were pair programming together for a bit, we figured out that it was just not necessary at all. So with that said, your think right here is, can you predict what Alexis will say? Do you think she'll say we need a new function, or no? Why or why not? So Alexis says no, and we can just give a negative number to the parameter if we want to subtract. Because when we add negative numbers to a score, that's the same as subtracting. So that's a pretty ingenious solution right there. And I'm thinking to myself, seriously, it was that easy? Well, don't forget that funny t-shirt I put in one of my lessons where it said weeks of coding saved me hours of planning. That's really true. The planning stage is probably going to be the most important stage in your programming experience. So here's what it looks like. Creating a function called checkCorrect, the button ID will be the parameter. So 1, 2, 3, or 4 will go here, and if the random button chosen is the same button that the player clicks, then you can update the score by 1. And then that 1 will go into this function, and this function will do its thing. Now, if you did not click the correct button, it's going to update the score by -3, which is logical. So -3 goes into there. Now what's going on down here? Well, it says if player 1 is the one who is getting either 1 or 3, then take player 1's score and add this amount to that score and reassign that score the results from P1 score plus an amount. Unless it was player 2 who got it either right or wrong, then player 2's variable is going to change. And notice right here, this function may have been created before it was defined, or it was called before it was defined. Right here, update score by, that connects right there. And so here's the thing about functions. I told you I would be telling you functions can be really tricky and confusing. You have to keep track of them. The way I like to think about it is, every time I create a new function, I feel like it's a raptor and I'm just an Ewok walking through the forest. These raptors, man, they can really mess up your code and get you stuck. You just have to keep track of them. And yes, our programming is becoming massive. When you go to read code for the first time, you'll see these function names and not have any idea what they're doing. I mean, if the programmer names them logically, you can take a guess as to what they're doing. But a lot of times, at least for me, I see a function name and then I have to hunt down where that function is defined in the code to understand what it's doing. And that can be an almost endless process. I find what that's doing just to discover another function inside of that function that I have to hunt down and try to figure out what that's doing as well. But needless to say, that whole process is pretty scary and daunting and takes time and takes focus. So let's take a step back here and really think about that function we just talked about. It's the update score function. And I think this would be a good moment for you to digest what we've just gone over by simply writing this code down on a piece of paper. But just to put your own little twist to it, what I'm asking you to do is combine these two console.log messages. I don't know why there's 2 lines of code here. We really could just have 1. So if you could do that, hand the paper to me, that would be great. If you're not in my class, you want to put it on the comments, go ahead. And piggybacking off of that last slide, I want you to think, what is the whole point of console messages anyways? I talked about it at the very beginning of the video. I gave you 2 big reasons why we need console.log messages. Now, whether you remember those or not, let's look at this console dump right here. And based on the picture, what is the importance of a console to a programmer? And be sure to reference things you're reading here in the messages. Okay, so after all that, what are we missing? Well, the UI needs to update the score. There are UI text labels for the player's score called score1 label and score2 label, and you can write the code to create this update. And my question is, can you write the code to create this update yourself? Even if you just take a moment to jot down some pseudocode, I want you to do that and give it a try. So here's the link to do that. And all we really need is a few lines of code placed into a function that is already logically named what we're trying to do. Update score. You'd benefit from testing and running the code yourself, so that's another reason to go to this link and start, trying to create on your own here. And just to be sure you've typed in the correct link, we are on bubble 21 right here. So back to the lesson here, we're almost done. Now there are lots of ways we can finish this game. Alexa says, what about first to get 3 wrong loses? That's tougher because we'd have to add a variable to count incorrect clicks for each player and add additional if statements. Then Michael says, I'll look into that. How about play until the difference in scores is greater than 5? Ooh, I like that one because it's a basketball reference. Or at least the way I used to play in the park, street ball that is, whoever wins will have to win by 2. So anyways, Alexis then goes on to say, well, they might play forever that way, so how about making it a team game? So play until the combined score is 20 or something like that. So Michael says, or play until combined they get 3 wrong. So that would be easier to count since we just need a single variable. My question here is, should we do things just because they're easier? Well, if you're an app developer, you need to do things to make the customers happy or do things to make the boss happy. But regardless, here's what they created. Here's the pseudocode. So they create a function called check game over, and I'll let you go ahead and read that. You should be a pro by now. Alexa says, so in check game over, if the game is over, you'll just switch screens right here and set some labels. Otherwise, you do nothing. Michael says, right, check game over will appear to do nothing most of the time because it's checking the conditions behind the scenes. So once the end of game condition is hit, the screen will switch. That's the end of their game. That's the end of our lesson here. So go ahead and pick an IB attribute trait that reflects today's lesson. And this is it. This is the hardest part of the day. I'm asking you to program a large block of code all on your own. So here's the link to that. Down here is just a reminder of what we ultimately have to do on the test. So we have to create code that is original and then write response to it. So the directions of the DOL right here is create a check game over function, make sure it works, then post it on Canvas. Don't forget to explain how your abstraction ends the game, that is aka narrate your code. So when you've created your check game over function, if you could just write a small paragraph under that explaining what you're thinking or what it's doing, that would be great. That'd give me a launching off point to give you feedback on how you're doing in terms of preparing for this test.